So today we're going to discuss the coal seam gas, or the extraction of coal seam gas, and its potential impacts on groundwater and the surrounding environment as an extension to how we're exploring how the extraction of mineral and energy resources could influence the environment. So first of all, what is coal seam gas? Well, coal seam gas is predominantly methane that is found in coal beds, and in terms of the Australian context, most of the economic deposits are located in the Surat and the Bowen basins in Queensland. How do we extract coal seam gas? We drill an extraction well through all the geology in these basins until we hit the coal seam proper. There they will either do horizontal drilling so that they can have various screens to be able to intercept the methane gas and to be able to extract it out. So then where does groundwater come into this? Well, in these sedimentary basins, we have quite a lot of successive sedimentary deposits that have happened in here as the basin and the basement have lowered due to tectonic forces. So we'll have a bit of a sand-rich layer over time, bit of clay-rich, sand-rich, clay-rich, bit of coal, sand, clay, clay. In each of these predominantly sand-rich deposits, the pore spaces in between the sand, the clay and the gravel that make up those deposits are filled with water, and that is what we call groundwater. So they occur in the sand deposits and also in these coal deposits as well. So for us to be able to get the methane gas, we need to be able to pump groundwater out from these coal seam deposits to depressurize this geology, and that helps to release the methane for that to be able to be extracted. So because we're removing groundwater from a coal seam deposit, there is the potential for groundwater to move from these relatively sand-rich deposits lying above and below the coal seam to be able to move into the coal seam and in turn also be extracted throughout this process. But how much this may happen depends on these clay-rich layers that I was talking about before that interbed these layers. So how thick they are, where they occur, do we have any fracturing in that clay? Clay itself is actually very hard for water to move through, and we call that an aquitard, so water retardant. So if we have a thick piece of clay with no fracturing in it, then water really can't make its way through that clay very well. However, if we have a bit of a thinner clay deposit, or we've got lots of cracks in it, then water has the potential to move up from these relatively sand-rich layers into the coal seam. And that in itself also has a lot of impacts down the track. So if we're moving water from these sand-rich layers, because sand is a relatively inert material, the groundwater doesn't tend to pick up a lot of salts from it, and it can actually be a very good store of fresh water, which is not only important for the streams and potential groundwater dependent ecosystems in the area, but it's also very important for the agriculture and the townships that are already established in these areas. And this is where one of the main concerns around coal seam gas extraction is. Will these environmental receptors still have enough water to be able to do what they want to do with it? Can we still sustain the townships? Will we still be able to sustain the environmental receptors?